Welcome everyone, my name is Mr. McGregor and in this video we're going to be looking at the different types of forces. So by the end of this video you'll be able to define the term force and name the four forces that we need to know in Year 11 that act on many everyday objects. So at its most simple definition, a force is a push or a pull. And that push or a pull happens because of the interaction between two objects. One object will push or pull on another object. We give force symbol F and it is measured in newtons, named after this guy, Sir Isaac Newton, who came up with three rules that we will be looking at later. One key thing about a force is that it acts in a particular direction. To help us with that, we draw forces as arrows to show both the direction that force is acting and the size of that force. For example, this arrow might represent a force to the right. This one is a bigger force to the right, and this one is a force up to the top left corner. There are four types of forces that we need to know at Year 11. Firstly is a thrust, and that's any force from an engine. It could be a plane or a car, or even our legs as we walk down the road. Opposing that is a friction force. Now that's any force that acts to oppose a motion, to stop an object moving in a particular direction. That could also be called a drag force, or air resistance or water resistance. The third type is the weight force. That's the force due to gravity, which always acts towards the center of the earth. And finally, the support force is any force that's holding an object up. That could be called a lift for a flying machine like a plane or a helicopter, or buoyancy for anything that is floating. Now I want you to pause the video for a moment and work out what forces are acting in each case here. We have a stationary rugby ball, a person walking at constant speed, and an aeroplane travelling at level constant speed. So let's see how you got on. Whenever we come to draw forces, always begin by putting a dot in the middle. That signifies the centre of mass of the object, and draw your forces out from there. In this case, we have a gravitational force or weight force acting down, and because the ball isn't falling, it must have an equal and opposite support force acting up. Those two forces also act for the person, but there is a thrust force from his legs moving him forwards, which has got an equal drag force slowing him down. Those four forces also act on the plane, but of course in this case they're much bigger. And you can see here that I've called the support force a lift force because it's flying. Let's talk about something called the net force. The net force is the overall force acting on an object. If the forces are balanced, then they cancel out and the net force is zero. If the forces are unbalanced, they don't cancel out and there will be a net force acting. If we look at this car, it's got a 5,000 Newton force of gravity and a 5,000 Newton support force. Because those forces are equal and opposite, they cancel out and there is no net force. If we look at this helicopter, if it's got 5,000 Newton gravity force, but a 7,000 Newton lift force, this means there's more force up than there is down, so they're not cancelling out. To find the size of that force, we use a subtraction. We see it as 7,000 newtons acting up. Let's look at this boat. It's not really moving up or down. The weight force is equal to the buoyancy force, 17,000 newtons each. Therefore, there's no net force acting up or down. But if these two engines are giving out 4,000 newtons of thrust each, we can combine that thrust to give us 8,000 newtons total thrust, and if there's 3,000 newtons of drag, that means the net force is 5,000 newtons to the right. And notice here how I've thought about the horizontal forces and the vertical forces separately. So by now you can define the term force, and you can name the four forces that act on many everyday objects: thrust and drag, weight force and support force. Thanks for watching.